So, today we're tackling something pretty fascinating. We're looking at how AI, one of the newest and most powerful tools we have, is being used to solve some of the oldest and most difficult puzzles in all of medicine. These rare neuromuscular diseases. All right, let's get into it. It's a pretty provocative question, isn't it? But it really gets to the very heart of what we're talking about today. We're going to unpack the science behind this idea, looking at both the incredible, almost sci-fi promise and, well, the much tougher reality of actually using AI in a real clinic.
You know, to really get why AI is even part of this conversation, you first have to understand the massive challenge that doctors are facing every single day. We're not just talking about finding a needle in a haystack here. It's more like trying to navigate a giant twisting maze in the dark. I mean, just look at this. We're talking about a huge family of illnesses, over 700 of them. Each one messes with the body's wiring and movement in its own way. And here's the really tricky part. So many of them look the same at the beginning. They often start with similar symptoms, like muscle weakness, which makes getting a clear, confident diagnosis incredibly tough. And to give you some scale, the main database for rare diseases, Orphanet, lists more than 6,000 of them in total. Neuromuscular disorders, they make up a really big piece of that pie. This means doctors are dealing with this huge library of conditions that they might only see once, maybe twice, in their entire career.
So let's just zoom in on one of these diseases to see how deep the rabbit hole really goes. Charcot-Marie-Tooth disease, or CMT for short, is the perfect example of what researchers call the diagnostic odyssey. And that's exactly what it is, a long, frustrating, and exhausting journey for patients just to get a name for what's happening to them.
And this right here just shows you how wild it gets. First off, there are more than 100 different types of CMT, and they all look a little different. Then you've got over 120 different genes that can cause it. But wait, it gets crazier. A single gene can cause multiple types of the disease. And if you zoom in on just one of those genes, you find hundreds of tiny variations, and only a small fraction of them are actually known to cause the disease. It is a puzzle wrapped in an enigma.
Okay, so you have this incredibly complex maze. Faced with this, researchers are turning to a powerful new guide, artificial intelligence. The hope is that an algorithm can see a path forward where even the most brilliant human experts get stuck.
So the whole idea here is pattern recognition, but on a massive scale. An AI can just chew through incredible amounts of data. We're talking genetic codes, patient symptoms, lab results, you name it. And it can spot these tiny, subtle connections that are practically invisible to the human eye. Think of it like a super doctor that can absorb the knowledge of thousands of cases in like minutes.
And what's really amazing is that this isn't just a theory anymore. Check this out. In a key diagnostic test called an EMG, which measures the electrical buzz in your muscles, AI models have shown absolutely stunning results. Some of these models hit up to 99% accuracy in classifying the signals, which means in some cases, they actually did better than experienced human specialists.
And you can bet the scientific community is paying close attention. As the researchers in the paper we're looking at today put it, there's some serious optimism that these AI tools can help untangle all this data, both the symptoms and the electrical signals, to get to a diagnosis way faster and more accurately.
Okay, so the potential is obviously enormous. But that brings us to the really crucial part of the story. It's time for the reality check.
It's the million-dollar question, isn't it? If AI can be this good, why isn't every doctor using it to help diagnose these incredibly complex diseases? Well, it turns out the answer is just as complicated as the diseases themselves.
Researchers have basically pinpointed 5 major roadblocks. First, with rare diseases, there just isn't a lot of data to learn from, and the data that does exist is scattered all over the place. Second, most AIs are only tested in the lab where they were built. They haven't been proven to work out in the real world. Third, sometimes the improvements are pretty small, not game-changing. Fourth, different hospitals use different terms for the same thing, making it a nightmare to combine data. And last, the tools are often clunky and just don't fit into a doctor's already packed workflow.
This slide right here, this sums up the biggest hurdle perfectly. In the lab, everything's neat and tidy. The data is clean, it's organized, it's standardized. But in a real clinic, oh man, it's the total opposite. Real-world data is messy. It's collected by different people, using different machines with different methods. An AI that was trained in the perfect world of a lab can completely fall apart in the chaos of a real hospital.
But it's not all bad news and roadblocks. Not at all. In one specific area, AI isn't just promising. It's already here and making a real impact. So let's look at where this technology is already a genuine success story.
And that success is happening in MRI analysis. Just look at these numbers. When AI models analyze muscle MRIs, they are achieving near-perfect scores in telling different neuromuscular diseases apart. That AUC score you see, it's a measure of accuracy. A 1.0 would be a perfect test. And these models are getting scores like 0.96, 0.98, all the way up to 0.99. That is incredibly good. Now here's the kicker. This success isn't just a research paper. It is translated into a real clinical tool. At least one AI software that automatically measures muscle health from an MRI has actually received clearance from the FDA. This is a massive deal. It means AI has graduated from being just a cool concept to being a regulated tool that doctors can legally use to help their patients today.
So what's it going to take to get more success stories like the one we're seeing in MRI? Well, the good news is researchers have actually laid out a pretty clear roadmap for bridging that gap between the lab and the clinic.
It's really a 5-step plan, and it's all about building trust. It starts with a simple idea. Define a real problem that needs solving. Then make sure your data is top-notch, and this is critical. You have to prove your tool works on new data from other places, not just your own. Then you've got to make it super easy for doctors to use. And finally, you can't just launch it and forget it. You have to keep watching it to make sure it stays accurate over time. It's a tough process for sure, but it's the only way to build tools that are truly safe and effective.
And that brings us right back to our big question. Look, this was never about algorithms replacing doctors. It's about creating a powerful new partner, a co-pilot that can help them navigate the incredible, beautiful complexity of human disease. The technology is moving at a breathtaking speed, but as we've seen, building trust, that's a marathon, not a sprint. So the question isn't really if AI will join the team anymore, but how do we make sure it's truly ready for the immense responsibility of the job?